All right, let's get started. So today's lesson is greatest common factor. But this is a technique that we use not just for factor trees like we did in Unit 1. We use this technique in order to factor polynomials. All right? So, example 1. Now, if you forgot what the word factoring is where you take an item and you break it down into a product. Now, it's true, we could do algebra tiles with this. So if you wanted to, you could open up the app, you could draw 6x squareds, 9x's, make a rectangle, go for it. But you know some of the rectangles might be wrong. Remember? We just did it a few minutes ago, and there was 3 answers. The only acceptable one will be the one that is factored out the most, the one that has the greatest common factor. So this is what we do. First, we need to think of these, and some of you might want to think of these broken into their smaller parts. So some of you might think of this as 2 times 3 times x times x. Some of you may think of 9 as 3 times 3 and x. And the first thing we're actually going to do is figure out what's common. It's not just a matter of the first thing that's common, it's what is as much as common as possible. Do they both divide by 2? No. 9 doesn't divide by 2. Do they both divide by 3? Sure, they each divide by 3. Do they each divide by x? Sure, they each have an x. Do they each have a second x? No. So guess what the GCF is? Right, it's what's common. Now, for those of you that did well in Unit 1, you're finding this is really easy because you did this with numbers already. So the GCF goes out front. Greatest common factor. Now remember, what we're kind of doing is the opposite of the distributive principle. So we just figured out what we're going to distribute. You guys got to come up with those of you that learn the analogy of bombing the castle, you got to figure out what the castle was. What am I going to distribute into in order to get an answer of 6x squared and 9x? Well, of course, it's what's left over. But before I write down what's left over, okay, I want you to remember that if you're going to end up with 2 terms in your question, you have to have 2 terms in the bracket. In order to end up with a binomial, you're going to have to distribute twice. Not once, not 3 times, twice. Because you know you end up with a binomial. And exactly what goes in these 2 terms, like I said, it's what's left over. There's a 2 here and an x, 2x. And there's just a 3 left over that I've not used, that I haven't divided out. Now this 3 that's left over is positive, so I'm going to put a plus. How can I check if I factored something? How do I know if I factored it properly? Multiply. Do what you're good at, right? We've been doing this lots. Let's try it. So to check this question out, you're going to go 3x times 2x is 6x squared. And 3x times 3 is 9x. You should get the same question that you started with. That's called GCF. Now, this technique works for more than one letter. Try this one. This technique can be used in the most complicated polynomial. All right, so this polynomial is called a binomial. This is a hard one because the degree, look at it. Each term has an x squared and a y. This is called a third degree polynomial because there are, in terms of exponents, x squared and y in each term, third degree. But the technique still works. Right now, I'd like everyone to write down what is common. between these two groups? What is the greatest common factor? Now, I tend to go in order. The first thing I do is the numbers. 8 and 16. What's the largest number that divides into 8 and 16? Keep going. Do a couple of those. Yeah. Bigger than 4, right? 8. 2 of those. Yeah, that's right. So remember, 16 is 8 times 2. They both divide by 8. All right? So that's the largest number. It's not the first number. It's not 2. It's not 4. It's 8. 8 is the largest number. Then I do the next letter. I ask myself, how many X's do they each have in common? Remember, it's in common. Right. Jessica's right. They each have an X. Only one X is common. This one's limited. How many Y's do they have in common? Just one Y. This one has one Y, this one has 2 Y's. How many do they have in common? Now, if I'm going too fast, you can write it all out and do the circling trick. But I think a lot of you can get GCF now pretty quickly in your head. So 8xy is what I'm going to divide out. Remember, factoring is division. So I am going to divide out the 8. I'm going to divide out the x, and I'm going to divide out the y. I'm going to pull them all out. Who can tell me what's left over? Once I pull out the 8, I pull out an x, and I pull out a y. What's left out of the first thing? This little 2 means you got 2 x's, right? So what's left over if I pull out one of the x's, one of the y's, and the number 8? What's left over? X. That's it. That's all that's left over. All right. Now, this is where some people have troubles. When you take out the 8, and it's my fault, because I shouldn't be saying take out the 8. When you factor out the 8, when you divide out the 8, divide it out. What's left over? Not 8. Right? It's division. Okay? You're also going to divide out an x, and you're going to divide out a y. What are the factors that'll be left over? 2y. Way to go. And it's positive 2y, so I put a plus 2y. So here's your check, you guys, if you understand today's topic. Check number 1. Is there anything in common here? Did I miss anything? Do these two groups have anything in common, the x and the 2y? No. One has an x, one has a 2 and a y. They have nothing in common, so that's a good thing. That means I pulled out as much as I could. Next, is this the right answer? And to check that, you do the distributive property. So 8xy times x, 8x squared, y, and 8xy times 2y, 16xy squared. Worked. All right? Now, this technique works for, This technique also works for any number of terms. So last example, example 3, 4a squared minus 6a, let's go with plus 2. So you can use this technique, greatest common factor, with any number. But what's tricky, you got to be careful here, is you have to find what's common to all terms. This is called a trinomial. And if this trinomial factors, you're looking for what's common to not the first 2, but all 3. So everyone write down what you think is common to all 3 groups, or all 3 terms. It's pretty simple, I think anyways, I don't know. So what's common? Can you do that in your head? What do you think, Jess? No, not both, 3. All 3 of them have 2 in common. Why don't they all have an A in common?
Because the 2 doesn't have an A.
Yeah, that doesn't have one. So this is 2 times 2, 2 times 3, 2 times 1. They all have a 2. This has A times A, no way, that's it. No other letter, no other number, that's it. 2 is the GCF. Now here's my question for you. If the question's a trinomial, what has to be inside the castle? Or what has to be inside the bracket? It has to be a trinomial. Because remember, when you distribute, and there's one thing in front, you better have 3 things in the bracket to get 3 answers. You need 3 arrows. to get it, 3 things. So please make sure if your original question's a trinomial, the bracket has to be a trinomial. Now, what goes inside the trinomial? What's left over when I divide 2 out? So I'm going to divide 2 out, I'm going to divide 2 out, and I'm going to divide 2 out. All right, who can tell me what's left over here if I divide the 2 out? 2a squared. Now, watch out for the sign here. I haven't done any negatives yet. This is take away 6a. I'm going to divide out the 2. I'm not dividing out the negative though. So the minus or the negative stays there. 6 divided by 2 is 3, and of course, a. And here's the one that people always get wrong. Guess what I see all the time? People write down, oh, we're done. I took the 2 out. I'm finished. And it's like, whoa, whoa, whoa. You're doing division. 2 divided by 2 is not 0. And if you don't know it has to be 1, now I can prove it has to be 1. How? Well, how do you check? Right. You distribute. And guess what you get if you distribute? 2 times 1 is 2. If that 1 isn't there, you do not end up with the trinomial. Okay? This is called GCF. This is the first type of factoring we're going to learn. And it will always be the first step of factoring. All right? For the next probably 3 or 4 lessons, of which will take us even after the Christmas break. Any questions? No. The quiz is on lessons 2 and 3 only. The quiz is not on factoring. Quiz is on multiplication only. Okay.